Hello everyone. In this video, I have discussed the nomenclature of alkane, alkene and alkyne using the IUPAC rules. I will share the nomenclature of other organic compound in my upcoming videos. If you find my videos helpful, then please like and subscribe to my channel. Let's get started. The nomenclature, that is the systematic naming of organic compounds, is based on the rule recommended by the International Union of Pure and Applied Chemistry, also known as IUPAC. The IUPAC name of any organic compound essentially consists of three parts, which are prefix, root and suffix. Let me first discuss the main building parts of any organic name that always exist, which is root. The root is the basic unit of the systematic name, which describes the carbon skeleton that shows the total number of carbon atoms present in the longest possible carbon chain belonging to the organic compound. For example, meth refers to a chain with 1 carbon atom and oct refers to a chain with 8 carbon atoms. Here I have tabulated the root words for carbon chain of up to 20 carbon atoms. If there are 2 carbon atoms, then the root word is eth. Similarly, for chain with 3 carbon atom is prop. You can have a quick look at the other root words, or you can also pause the video. Now coming to the other two parts, prefix and suffix. The root word may have some atom or group of atoms attached to it, which are referred as substituent. If the substituent is written before the root word, then it is termed as a prefix, and if it is written after the root word, then it is termed as a suffix. In general, a prefix is used to denote the side chain in the organic compound, while a suffix denotes the functional group present in an organic compound. Some prefixes are also used to indicate the cyclic or acyclic nature of the organic compound. These prefixes are known as infixes. Here I have tabulated some commonly used prefix. CH3. The prefix for CH3 is methyl. CH2, CH3, ethyl. CH2, CH2, CH3, propyl. You can have a look at the other prefix for saturated aliphatic substituent, or you can also pause the video for other substituents which are commonly used. The prefix for doubly bonded CH2 is methylene. Prefix for CH double bond CH2 is ethinyl. CH2 CH double bond CH2 allyl. C6H5 phenyl. C6H5 CH2 benzyl. If the saturated hydrocarbon substituent is abbreviated as capital R, the prefix alkyl is used. OR alkoxy. Halogen as halo, for example chloro and bromo, and O2 as nitro. Here is a suffix used for singly, doubly and triply bonded carbon bonds. For saturated carbon-carbon single bond, the suffix "ane" is used. For unsaturated carbon-carbon double bond, the suffix "ene" is used, while for unsaturated carbon-carbon triple bond, the suffix "ine" is used. This is the overall table comprising all the substituents found in various organic compounds. The prefix and suffix of each substituent are tabulated. I will discuss this table in upcoming videos of this series. Let us first discuss the naming rules for alkane. For linear alkane with no branch, the naming is quite simple and is done just by adding the suffix "ane" to the root name. For example, in CH4, there is only 1 carbon atom, so its root name is meth. Suffix "ane" is added to its root name meth while writing is IUPAC nomenclature that gives methane. In CH3, CH2, CH3, there are 3 carbon atoms, so its root name will be prop. Consequently, its nomenclature is propane. Similarly, the IUPAC nomenclature of 6 and 8 carbon atom based linear alkane is hexane and octane respectively. For branch alkane, I have summarized various rules for naming, which are: first of all, the longest possible chain of carbon atoms must be selected. This chain is also known as parent chain. Consider the example of this branch alkane. If you include the carbon atoms of the branch chain, then there will be 7 carbons in the chain. While if you consider the carbons of only linear chain, then there will be 6 carbon. So, the branch chain having 7 carbon atom is the longest possible chain. Now, number the carbon atom of the selected chain such that the carbon atom carrying the alkyl substituent gets the lowest possible number. The carbon atom attached to the methyl substituent in this compound can have 2 numbers. If the numbering is carried out from the left end, then the carbon will get second position. And if the numbering is carried out from the right end, then the carbon will get third position. So, as per the rule, numbering from the left hand side is correct. The number given to the such carbon represent the position of alkyl substituent. The number that indicate the position of substituent is called locant. The number followed by the hyphen is written before the alkyl substituent. The word locant is basically derived from the word location. So, the correct name of this compound is 2-methyl butane, not 3-methyl butane. If 2 different alkyl groups are present at an equal distance from either end of the selected chain, the alkyl substituent which comes first in the alphabetical order gets the lowest possible number. Consider this compound. Here we have methyl as well as ethyl substituent, and both of them are equidistant from either end of the chain. Since alphabetically ethyl will come first, we will give the lowest possible number to the ethyl substituent. So, the correct nomenclature of this compound is 3-ethyl-4-methyl hexane, not 4-ethyl-3-methyl hexane. Least sum rule. If the 2 alkyl substituents are present and the branching occurs at an equal distance from either end, the numbering must be carried out from the end which give a minimum possible number to both substituent. If the numbering is done from the left end, the 2-methyl substituent will get locant number 2 and 4, whose sum is 6. And if the numbering is done from the right end, the 2-methyl substituent will get locant number 3 and 5, whose sum is 8. So, former numbering, that is from the left end, is correct. Rule of first point of difference. The least sum rule is valid only for chains with 2 substituents. For more than 2 substituents, the rule of first point of difference must be used. When a series of locant containing the same number of terms is compared term by term, a series that contain the lowest number on the occasion of first difference is preferred. Consider this example. From the left end, the locant are 3, 4 and 9, while from the right end, the locant are 2, 7 and 8. However, 2, 7, 8 is preferred as it has the lowest number, that is 2, on the first occasion of difference when compared with the other set 3, 4 and 9. Suppose in a compound the first locant from the both ends is the same, then we will compare the second locant. The lower locant will be preferred. However, one should keep in your mind that different alkyl substituents are written in alphabetically order irrespective of their position in carbon chain. For example, the correct name of this compound is 3-ethyl 2-methyl pentane. Even though the ethyl substituent get a higher number alphabetically, it comes first. So we should also write its name first. If two or more similar alkyl substituents are present in a compound, the word di, tri, tetra, and so on are used to specify the number of times these alkyl substituents appear in the chain. The prefix is not considered for writing the alphabetically order. In this organic compound, there are two methyl substituents. So based on the locant and other substituent is IUPAC name is 4-ethyl 2,3-dimethyl hexane, not 2,3-dimethyl 4-ethyl hexane, as di will not be considered while writing the alphabetical order. An important point must be noted that groups like secondary butyl and tertiary butyl are alphabetized under B. However, isobutyl and isopropyl groups are alphabetized under I, not under B or P respectively. That is, the prefix iso of isobutyl is considered for writing the alphabetical order. If the alkyl substituent is a branch chain alkyl group, then it is numbered separately. The numbering of this branch substituent starts from the point of attachment to the parent chain. The branch chain alkyl group is always written in a bracket as a prefix. In this compound, the substituent is 1-methyl propyl, whose locant is 5. So its nomenclature is 5 hyphen in a bracket 1 hyphen methyl propyl bracket close nonane. 1-methyl propyl is also known as secondary butyl, so its nomenclature can also be written as 5 hyphen secondary hyphen butyl nonane. Consider some example of alkane. In this organic compound, the longest chain contains only 3 carbon. So 1, 2, 3. 2-methyl substituent from the second carbon, hence its nomenclature is 2,2-dimethyl propane. In the second organic compound, there are 7 carbons in the parent chain. The numbering can be done from either end as the organic compound is symmetrical. There are 2-methyl substituent at the position number 3 and 5. Hence, its IUPAC nomenclature is 3,5-dimethyl heptane. In this organic compound, there are 7 carbon in the parent chain. If the numbering is carried out from the right end, the 2-methyl substituent will get position number 3. And if the numbering is carried out from the left end, the 2-methyl substituent will get the position number 4. Hence, its nomenclature is 3,3-dimethyl hexane, not 4,4-dimethyl hexane. In this organic compound, there are 6 carbon in the parent chain. If numbering is carried out from the left end, the 2 substituent will get position number 2 and 4. And if the numbering is carried out from the right end, the 2 substituent will get position number 3 and 5. So, the numbering from the left end is correct. Hence, its IUPAC nomenclature is 4-ethyl 2-methyl hexane, not 2-methyl 4-ethyl hexane, as alphabetically ethyl will come first over methyl. In this organic compound, there are 7 carbon in the parent chain. If the numbering is carried out from the left end, the 4 substituent will get position number 3, 4, 5 and 6. And if the numbering is carried out from the right end, the 4 substituent will get the position number 2, 3, 4 and 5. So the numbering from the right end is correct based on the rule of first point of difference. Hence, its IUPAC nomenclature is 4-ethyl 2,3,5-trimethyl heptane. Similarly, there are 7 carbon in the parent chain of this organic compound. The numbering from the right end is correct based on the rule of first point of difference. Hence, its nomenclature is 4-ethyl-3,3-dimethyl-heptane. In this organic compound, there are 8 carbons in the parent chain. The numbering can be carried out both ways. However, the first way is preferable, as the branching of the substituent should be avoided as much as possible. Hence, its preferable IUPAC nomenclature is 3-methyl-4-propyl octane, not 4(1-methyl-propyl) octane. In this organic compound, there are 7 carbons in the carbon parent chain. We can also carry the numbering in both ways. However, the first way is preferable, as the branching of the substituent should be avoided as much as possible. Hence, its preferable IUPAC nomenclature is 3,5-dimethyl-4-propyl heptane. Now coming to the alkene. The basic rules for alkene remain the same as for alkane. Some additional are as follows. The longest chain is given the name by the suffix "ene" in place of suffix "ane" as in alkane. For example, 3 carbon base alkene is propene, while 4 carbon base is butene. The longest carbon chain should include the carbon of a double bond, but it is not compulsory. In this compound, we can select the parent chain in 2 ways, and both of the ways give a 6 carbon chain, base parent chain. However, the first one is correct as it includes the carbon of a double bond. If the parent chain gives more carbon count without considering the carbon of a double bond, then we may not consider unsaturated carbon, or that is double bond, in the parent chain. For example, in this compound, if we consider the unsaturated carbon, then the parent chain will have 6 carbon only. So the correct one is the second one, as it consists of 7 carbon in the parent chain. The first carbon of the double bond gets the lowest possible number. Like as you can see in these example, the numbering will start from the doubly bonded carbon at If a substituent is also present in the parent chain, then the carbon atom of the double bond gets the preference over the substituent while numbering. In this organic compound, if the numbering is carried out from the right end, the doubly bonded carbon atom will get the position number 2. And if the numbering is carried out from the left end, the doubly bonded carbon atom will get the position number 4. So numbering from the right end is correct. However, if the carbon atoms of double bond get the same locant, that is the same number from both ends, then numbering should be carried out from the end that give a lower locant or number to the substituent. In this organic compound, the locant or number remain the same at both ends. I mean for doubly bonded carbon atom. So the numbering is carried out from the left end to give the lower number to the substituent. In an alkene, the position of the double bond is indicated by placing the number before the suffix "ene". In this organic compound, the position of doubly bonded carbon is 3, while ethyl substituent is located at 5th position, so its name will be 5-ethyl-hex-3-ene. Similarly, the name of the second compound is 4-methyl-pent-2-ene. If the position of the double bond is 1, then it is not compulsory to indicate the number before suffix "ene". For example, prop-1-ene can be written as propene. If more than one double bond is present, The location of each double bond is indicated just before the suffix. The suffix used for the 2 double bond is diene. For 3 double bond it is triene, and so on. In such compound, suffix A of alkane will be retained. There are 6 carbon in the parent chain and the double bond are at position number 1 and 3. So its IUPAC nomenclature is hexa-13-diene, not hex-13-diene. There are 5 carbon in the parent chain and the double bond are present at position number 1 and 3. There is one methyl substituent at position number 4. So its name is 4-methyl-penta-1,3-diene. Similarly, buta-1,3-diene, hexa-1,3,5-triene. This organic compound has 6 carbon in the parent chain. There are 2 alkyl substituent at locant number 3 and 4. So 3 hyphen in a bracket 1 methyl ethyl, 4 methyl hex 1 ene. Since 1 methyl ethyl is also known as isopropyl, so its IUPAC nomenclature can also be written as 3 isopropyl 4 methyl hex 1 ene. In this compound, if we consider the unsaturated carbon, then the parent chain will have 6 carbon only. So the correct one is the second one, as it consists of 7 carbon in the parent chain. So its IUPAC nomenclature is 3,5-dimethyl 4-vinyl heptane. Alkyne. For alkyne, the basic rule remains the same as for alkane and alkene. The longest chain is given the name by the suffix "-ine". The longest chain should include the carbon of a triple bond and the lowest numbering is given to the first carbon of the triple bond. For example, ethine, 4 carbons and triple bond at position number 2. So, but-2-ine. In this organic compound, there are ethyl and methyl substituent at position number 3 and 4 respectively. So its IUPAC nomenclature is 3-ethyl 4-methyl hex 1-ine. In this compound there are 2 triple bonds, so A of pent will be retained. So its IUPAC nomenclature is 3-methyl-penta-1,4-diene. When both of the double bond and triple bonds are present in the organic compound, the numbering is carried out using the least sum rule, so that the unsaturated carbon get the lowest possible number. For example, hex 3-ene-1-ine. However, if the double and triple bond are equidistant from both ends, then preference is given to the double bond. For example, but-1-ene-3-ine. Consider some more examples. It is a 7 carbon based compound. Using the least sum rule, its IUPAC nomenclature is hept-2-ene-4-ine. Here in this example, the double and triple bonds are equidistant from both ends and will get the same locant. But as per the rule, the double bond will get the preference and its name will be oct-2-ene-6-ine, not oct-6-ene-2-ine. In this organic compound, the preference is given to a triple bond as it is nearer to one end, and its IUPAC nomenclature is oct-6-ene-1-ine. Now I end this video here. Thanks for watching. If you find my videos helpful, then please like and subscribe to my channel. See you in the next video of this series.